When people generally look at the universe or think about it, what comes to mind are explosions, uninhabitable conditions, and chaos. However, in reality, the universe possesses an extraordinary order in one way or another. The fundamental building blocks of this order are the laws of physics. Today, together, we will explore the details of the laws of physics, discuss whether they have to be the same everywhere, and answer the question of what would happen if the laws of physics did not exist. Before we move on to the video, don't forget to support me by subscribing to the channel, liking the video, and sharing your thoughts in the comments. If you're ready, let's begin. As I mentioned, when we look at the universe, the first thing we notice is not chaos, but order. This order sometimes includes harsh conditions, sometimes an elegant beauty, and yes, sometimes it can be cruel, but none of these are signs of chaos or disorder. On the contrary, they show us that nothing is truly random. The birth of a star, the vibration of an atom, or the beating of our heart, all of them occur within an invisible yet unavoidable framework. This framework is what we call the laws of physics. However, this term is often misunderstood. The laws of physics are not written rules hanging on the walls of the universe. They are unavoidable patterns that emerge when we observe how the universe behaves. For example, a stone falling to the ground, light being unable to travel faster than a certain speed in a vacuum, or energy not being created out of nothing. These things do not happen because they should. They happen because the nature of the universe cannot behave in any other way. For a large part of humanity's history related to space, the idea that these limits were universal did not even cross people's minds. Humans believed that nature was special to Earth and to humanity itself. However, later observations and studies showed us that wherever we look in the universe, we see the same physical behaviors. That is why almost everything in space, and in fact everything, is examined within this framework. A supernova explosion occurring in a galaxy millions of light years away behaves in the same way as one in our own galaxy. Because of this, scientists argue that everything must occur according to certain physical laws. Moreover, one of the strongest pieces of evidence that every corner of the universe belongs to a single reality is black holes. This is because the matter orbiting a black hole can be described using the same mathematical equations as fluid dynamics here on Earth. If there were not a single reality or a single set of truths, we wouldn't even be able to study other stars and galaxies. Perhaps we wouldn't even be able to go into space at all. A spacecraft is designed according to specific laws of physics and travels based on them. If physical laws did not exist, the probability of a spacecraft exploding the moment it left the atmosphere would be extremely high. The same applies to experiments. If there were no universal constants, an experiment conducted on Mars could not be compared to one on Earth, and no meaningful conclusions could be reached. In light of these conclusions and observations, today we know very well that the laws of physics and physical constants are real, that they are not lies or fabrications. However, as with any subject, there is also a group that claims the opposite, much like flat Earth believers. The laws of physics have a tremendous impact on our planet and on life on Earth. Every physical process is in fact a reflection of universal laws. Gravity binds us to the ground, keeps the atmosphere surrounding the planet, and allows oceans to exist. Electromagnetic force holds atoms together, forms chemical bonds, and lays the foundation of biology. Without the strong nuclear force, atomic nuclei would fall apart. Without the weak nuclear force, the sun would not be able to burn. As you can see, the universe balances itself in such an elegant way and is built upon certain laws that, as a result, give rise to a universe that we cannot fully observe today and most likely never will. However, there is an important point I need to warn you about. When talking about these topics, some people mistakenly believe that the laws of physics somehow aim for life or that they exist for life. In reality, this is not the case. The laws of the universe do not aim for life. Life is merely a temporary order that emerges within the narrow range allowed by these laws. If the universe truly aimed for life, we would find traces of life, even just microorganisms, on every planet and even on every moon. Now let's move on to one of the most critical questions. What would change if these laws of the universe, or universal constants, however you choose to call them, were slightly different? First of all, as mentioned earlier, fundamental constants such as the speed of light and the strength of gravity allow life to exist only within a very narrow range. Outside this range, stars could not form, atoms would become unstable, or the universe would collapse within seconds. This is why the universe is often described as being finely tuned. However, what remains debated is whether this tuning is intentional or inevitable. According to some physicists, the universe could not have been any other way. The laws represent the only possible way for existence to occur. According to others, there may be countless universes that we have not yet discovered, and we simply happen to live in one of the rare universes where life is possible. Which one do you think makes more sense? Honestly, to me, both do. In my own view, if other universes exist, they may have have their own unique sets of laws. In that case, gravity might be ideal for life on Earth at one specific level, while in other universes life could exist with much stronger or much weaker gravity. Contrary to what is often believed, Earth is not physically privileged compared to the rest of the universe. None of the laws operating here are special on a cosmic scale, such as the examples we mentioned earlier. What makes Earth unique is the fact that these laws come together in an extremely delicate balance. When this balance is disrupted, the planet does not simply become uninhabitable, it ceases to be a planet altogether. I would like to discuss in more detail the effects of gravity, electromagnetic force, and the laws of thermodynamics on our planet and on life itself. Gravity is often described as the silent architect of life on Earth. Thanks to its finely tuned strength, our atmosphere does not escape into space and our oceans remain stable. This is what allows life to emerge and evolve. At the same time, gravity is weak enough that living beings are not crushed by it. They can move freely and build complex structures. If this force was stronger than it is, the atmosphere would become extremely dense and surface pressure would reach lethal levels. The same principle applies to the electromagnetic force. This force, which holds atoms together and makes chemical bonds possible, forms the very foundation of biology. The stable structure of DNA, the folding of proteins, and the formation of cell membranes all arise from it. If this force was slightly stronger, atoms would bind too tightly and complex molecules could not form. If it was slightly weaker, atoms would become unstable and chemistry itself would collapse. The laws of thermodynamics, on the other hand, determine the direction of life. Entropy disorder tends to increase throughout the universe. At first glance, this may seem to contradict life, since living systems are highly ordered and must remain so. But in reality, life is not an exception to entropy, it is a temporary and local expression of it. Living organisms maintain their internal order by drawing energy from their surroundings, while at the same time increasing the overall disorder of the universe. In other words, life is not a violation of thermodynamic laws, but an inevitable result of them. Here, the sun becomes a crucial factor for us, because the energy it provides acts as the engine of this entire process. If light did not travel at a specific speed, or if the nature of electromagnetic waves were different, the radiation coming from the sun would lose its meaning and photosynthesis would not be possible. Without photosynthesis, none of the biological evolution we know today would have occurred, and life would not exist. I would also like to emphasize that the laws of physics should not be seen as obstacles or limitations. On the contrary, it is precisely their consistency that allows us to make remarkable progress in science and space exploration today. If physical laws were variable, we might not even be able to use water properly on our planet. So there is no need to view the laws of physics as an enemy. You might be thinking, who would see physics as an enemy anyway? But believe me, there are still a considerable number of people today who believe that the laws of physics are somehow wrong. In a universe without physical constants, even time would not exist as we understand it. In our universe, concepts like before and after make sense. In a universe without physical constants, such concepts would disappear. Causality would collapse, effects could occur without causes, or causes might produce no effects at all. The moment you imagine a universe without physical laws, you are confronted with this kind of absurdity. Even in a universe where physical laws exist but constantly change, similar problems would arise. For example, the formation of a star takes millions of years. If physical laws were continuously changing during that time, the star would be destroyed before it could even fully form. And even if stars somehow did form, the lack of any stable order would make life impossible. In short, the crucial point is not merely the existence of laws, but their stability. If I had to give a clear and direct answer to the question, is life possible without the laws of physics? The answer would be no, absolutely not. Because what we call life is, at its core, interaction. If something exists, it interacts with something else, and if it interacts, it must follow a set of rules. Of course, some things we believe today may change in the future. For example, environments we currently consider completely uninhabitable may one day be found to host life, or we may discover forms of life we have never encountered before. But this does not mean that the laws of physics are false or imaginary. It simply reflects humanity's lack of knowledge at a given moment. For many centuries, the Earth was believed to be flat, and those who argued otherwise were excluded from society and faced severe punishment. Yet over time, thanks to technological progress and the accumulation of knowledge, we proved that the Earth is not flat in any way. The fact that this understanding changed later did not alter the reality that the Earth is geoid. That truth was always there. The laws of physics are no different. If in the future we discover that something written in the laws of physics is not exactly as we thought, this does not mean those laws were imaginary. It simply reveals our own ignorance and limitations. In short, the laws of physics are a necessity. Nature or the universe has no alternative. Life itself has emerged within an extremely delicate balance of this necessity. Without the laws of physics, life cannot exist. However, if other universes exist, even theoretically, each universe may have its own unique set of physical laws. In this sense, the laws of physics are also a philosophical subject because they involve concepts such as causality and existence. Without physical laws, life itself would lose all meaning. This is a direction where the discussion could easily become philosophical, but our focus here is science, space, and observable reality. For that reason, I don't want to extend the video any further, and I'll ask your permission to move on on and start working on the next one. Before you go, don't forget to subscribe to the channel, like the video, and leave a comment. See you in the next video. Take good care of yourselves.